مرة أخرى في هذه الجلسة الافتتاحية الأولى من اليوم الرابع حضوريا للمؤتمر الدولي الثاني للتعليم والتكنولوجيا والقانون تحت شعار الابتكار رهان ضمن الخيارات الاستراتيجية للتنمية. وضيفنا اليوم ضيف الشرف الأستاذ والدكتور والباحث المخترع والعالم المغربي البروفيسور رشيد اليزمي. سيلقي اليوم كلمة افتتاحية بهذه المناسبة. مرحبا دكتور، الكلمة لكم. شكرا جزيلا على قبول الدعوة.
شكرا على الاستضافة، وأهلا وسهلا بك نبيل والحاضرين لهذا المؤتمر. إذا واش لازم لما نتكلم بالعربية ولا بالإنجليزية؟ لا،
كما تشاء سيدي.
كما شاء. أفضل الإنجليزية لأن هذا يعني slides are in English, so we speak in English. Okay, so thank you again for having me today, and I would like to speak very, say, briefly about my personal, journey in the battery science. So the title is From the Graphite Anode to the Ultra Fast Charge, 44 years dedicated to lithium-ion battery science, technology, and entrepreneurship. Okay. All right, so let's see. It's working. Okay, so first of all, I would like to acknowledge all the institutions in which I have been working since 1978, when I started my research work, starting with the Grenoble Institute of Technology, the CNRS. I joined the CNRS in 1985 after I passed my PhD on lithium batteries. Then 4 years later, I moved to Kyoto University, where I spent about 2 years. I learned a little bit of Japanese language. Then I come back to Grenoble in 1990. Continued my research work at the Grenoble Institute of Technology and the CNRS. And then in 2000, the year 2000, I moved to the California Institute of Technology and worked together with the Jet Propulsion Laboratory of NASA. And that was for about 10 years. And in 2010, I moved to Singapore, specifically to the Nanyang Technological University, where I am still here. I mean, I'm still working indirectly with them, but I actually, I have to say, dedicated 100% of my time to my company KVI, Kelvin Volta Innovation in Singapore. So as you see, I have a background on academia research, but also entrepreneurship. KVI is a company that I founded in 2011 here in Singapore. Okay, and this is dedicated to advanced batteries, especially battery management systems, and to make batteries safer, last longer, and also fast charging. So for those who do not know me, I am recognized as the father of the graphite anode for lithium-ion batteries. In 2014, I was recognized by the Draper Prize, which is given by the National Academy of Engineering in Washington, D.C. And the Draper Prize is considered the Nobel Prize for Engineering. And that was actually a turning point in my career, because when you get the equivalent of a Nobel Prize in engineering, necessarily you attract more attention from academia and also from the press and from, in general, the people I meet in the street in Morocco. They recognize me and they say hello to me. Okay, so briefly, the Draper Prize, everything you have in your cell phone, all the technologies that you have in cell phone have been recognized by the Draper Prize. Okay, so starting with the 1989, the integrated circuits and the Fortran, the satellite communication and internet and the GPS and the network PC and the CCD, the crystal display, and the WWW and the Kelman and the LCD, etc., etc. So I don't want to go all over this, but in 2014, as you can see, there are the LIB, which is the lithium-ion battery, and then there was the LIDs and the programming and microelectronics and so on. So it's mostly about successful engineering achievements that has changed the world. Okay, that's what the Draper Prize recognizes. So these are the pictures back to the Draper Prize ceremonies in 2014. And as I said, it is in the Washington, D.C., around maybe 500 meters from the White House in Washington. And these are the 4 laureates in 2014, starting by Dr. Yoshino, who actually worked for Asahi Chemicals, Professor John Goodenough from the Texas University in Austin, and Mr. Nishi from Sony, Japan, and myself. Okay, so basically, to make a very short story, in the same year of 1979, 1980, both John Goodenough and myself, we discovered the cathode for John Goodenough and the anode for myself, almost the same year. And it took about 5 years to Dr. Yoshino to put together in a prototype the lithium cobalt oxide cathode discovered by John Goodenough and the graphite anode discovered by myself to the first working battery. And it was very, of course, successful developments and crucial developments because unfortunately I didn't know the work of Prof. Goodenough at that time. But anyway, it went to Japan. And then Mr. Nishi from Sony, it took him about 6 years to commercialize the lithium-ion battery, to mass produce it. And the first lithium-ion battery were used in a mobile device, which is the Walkman by Sony. And then it's extended to mobile phones and smartphones and iPhones, etc., etc. So today, 100% of cell phones use the graphite I invented and a variant of the cathode developed by John Goodenough. Okay, so I would like to show you this video about what happens every time you charge your battery, what happens on the graphite side, on the anode side. The anode, by the way, is the negative pole of the battery. So it's a very short video that I have done with a colleague of mine from General Motors in the United States. And you can see actually the changes in the color of the anode during the process of charging. So you see the color changing, and then you have the red color from the bottom and becoming more gold color as you continue charging the battery. And then when the battery is fully charged and you discharge it, you see that the color turned back to black, which is the initial state of the graphite. So this operation happens every time you are charging your battery. If you can look inside your battery, you can see that the anode is converted from black color to gold color. And gold color is the sign, the evidence of the lithium intercalation between the graphene layers in the anode side. Okay, so this is really a phenomenon, and I can tell you that the first day I opened my cell and I found that the graphite turned to gold color, I was very, very happy. Okay, so that was a very important discovery that make batteries rechargeable. Okay, so as you know, lithium-ion battery is now used in a very, very wide variety of systems, from power tools, smartphones, etc., and the amount, the number of applications or systems that use lithium-ion battery is increasing every year. So very soon we will see airplanes, electric airplanes, besides, of course, electric vehicles like cars, trucks, buses, and trains, and so on. But also very soon, we also already have drones, many drones use lithium-ion batteries, and as a result, they are more silent. And as I said, very soon there will be airplanes that will use lithium-ion batteries today. Some prototypes of airplanes can fly for about 1.5 hours, and with a distance of about 500 kilometers range, which is not so bad. Okay, and of course we will see very soon ferries and boats, especially maybe fishing boats using lithium-ion batteries. And here in Singapore, I work with a company who has developed some electrical boats that go from Singapore to neighbor countries like Indonesia and Malaysia. Okay, other applications is the so-called the energy storage system, where we will use the clean energy, renewable energy from solar, wind, and hydroelectricity, store energy in batteries, and then use it in factories, offices, and so on, and homes. And by doing this, we increase the efficiency, the energy efficiency of the system, because storage is the center of everything. And as a result, also the cost of the electrical energy, the dirham per kilowatt hours, or the dollar per kilowatt hour, will drop significantly because of the energy storage. All right, the markets of lithium-ion batteries in 2020 was about $80 billion, and in 2030, it will reach the $200 billion. And this is the how the market is distributed from power tools, forks, telecommunication, UPS, and electric vehicles, and so on. In Europe, there's now more than 20 companies that will build so-called gigafactories, and with the prospects of producing 500 gigawatt hours in 2028. It's very soon. So Europe started from a very few gigawatt hours in 2020, and will grow to 100 this year, 150 gigawatt hours, and 500 gigawatt hours in 28. And this is, of course, to enable the electric cars made in Europe, especially in Germany, in France, and Italy, to run with batteries. Okay, so there are still some, of course, issues with the lithium-ion batteries, and I would like to summarize very quickly what are the current problems and how we solve them. So number one is safety. So you may have heard that batteries from time to time catch fire or explode, and this is unfortunate, and this happens almost every day. By the way, in China, it seems that there are about 10 electric vehicles a day that catch fire. 10 cars every day catch fire because of the quality of the batteries, or because of the poor management of the battery. So batteries can catch fire. The other issue is the long charging time. Today is minimum is 1.5 hours to fully charge, but this one we would like to shorten it or reduce it to below 30 minutes. The other limitation is the driving range. How many kilometers can we drive a car after fully charged? So today, commonly, most of the car can provide about 250 to 300 kilometers, but some cars also have up to 500 kilometers. but this is not enough. We would like to increase it to 900 kilometers every time. And also the last but not the least is how many years can we keep a battery in your electric car. So today is about 2 to 5 years, and this should extend to 10 years. Okay, so the fire, this is something we don't want to see. And I would like to go very fast about, how we solve the safety problem of batteries. So we developed a technique called entropimetry, and this technique is very strong because we can determine the state of charge, state of health, and state of safety of batteries. And I will go very fast to the safety. So the safety of batteries, usually what's the origin of a fire in a battery is the occurrence of an internal short circuit. It means that the anode and the cathode are in physical contact, which means that there is a current inside the battery that is developing. And as a result, because of the Joule effect, there is a heat generated. And if the temperature exceeds some limits, there is a risk of fire or explosion. And what we found here is that if we measure entropy of a battery, we can determine whether a battery, a cell, has an internal short circuit. And for instance, if I drive, this is just an example for this battery, if I drive the voltage to 3.7 volt, and I measure the entropy of the battery and the enthalpy of the battery, we can see that according to the occurrence of internal short circuits, we can see a difference in the entropy value in this diagram, entropy versus enthalpy. So this is very simple, very strong method. And we are in the process now with some electronics companies, giant companies, to develop a chip that will be embedded in every cell and can detect an early stage of an internal short circuit in the battery. Now, the fast charging, instead of using constant currents, we apply so-called NLV, nonlinear voltammetry. And the nonlinear voltammetry, basically, we apply a constant voltage, steps of constant voltages, and then we follow the current. So there is a relationship between the applied voltage and the current profile. So the current here is in blue color, and the voltage is red. And you can see here that within the same voltage plateau here, we have a rest time, and that rest time enables us to control the temperature of the battery. So today we have a world record, that is, we are able to charge a battery in 6 minutes. You can see here the NLV profile of a battery that we charge in 6 minutes, and this is a world record. Okay. I think this, I would say, development of the NLV will totally change the way how batteries will be charged in the future, and especially for electric vehicles. Okay, so I think I will stop here. There are lots of things I can say. Unfortunately, the time is running, and I have to leave my office now. It is almost 5:20 p.m. in Singapore, and I would like to thank you again very much for having me. And I hope I could have more time. Anyway, next time I will be present with you. I was in Morocco last week until Saturday. So I missed coming to Meknes and giving this lecture, before everybody. Thank you very much. Thank you.
شكرا لكم بروفيسور رشيد اليزمي على مداخلتكم المتميزة والرائعة ومساركم الحافل بطبيعة الحال بالإنجازات، والذي هو تتويج وتحفيز لكل متعلم وكل طموح من أجل تحقيق الأهداف المنشودة. بفضل اختراعاتكم سيدي، نحن الآن نتواصل معكم عبر هذه الوسائل التكنولوجية المختلفة بما فيها سمارت فون، لابتوب وما إلى ذلك. بفضلكم نحن الآن نتواصل بهذا الشكل، وأنتم الآن من سنغافورة ونحن الآن في المغرب، يعني فرق تقريبا 7 ساعات، ومع ذلك فإننا نتواصل بكل سهولة. للإشارة فالسيد البروفيسور رشيد اليزمي له أزيد من 120 براءة اختراع، و يعني مؤخرا هناك بما فيها الحل النهائي لانفجار البطاريه، لان هذا مشكل كبير. يعني كيف كنقولوا بالدارجه، كاين اللي كيشارج البورتابل حتى لواحد الوقيته كينفجر، ولكن هذا اختراع من بروفيسور رشيد اليزمي، ووجد حلا مثاليا لحمايه البطاريه من الانفجار، بالاضافه الى الاختراع كما قال الريكورد. يعني هو مؤخرا أن يمكن ملء البطارية كاملة في 6 دقائق. من قبل كان الاختراع في 20 دقيقة على ما أعتقد البروفيسور، و10 دقائق، والآن فهذا يعني إنجاز كبير في 6 دقائق. فننتظر منكم ونتمنى إن شاء الله منكم سيدي المزيد من الاختراعات التي ستساهم إن شاء الله في الرقي بالبشرية بشكل عام، كما فعلتم مع الاختراعات السابقة الذكر اللي هي كثيرة جدا. وإن شاء الله نتطلع إلى أن نلقاكم مباشرة، فمرحبا بكم في بلدكم، فهو بلدكم الأول والثاني والأخير، المغرب. نشوفكم إن شاء الله في مكناس حضور. كان بالإمكان أن السيد رشيد اليزمي يعني أن يكون معنا كذلك في الجلسة الافتتاحية الأولى ليوم السبت، لكن للأسف يوم السبت كان مسافرا، ووصوله إلى سنغافورة يوم الأحد، لذلك فهو مع ذلك لم فقبل الدعوة مرة أخرى، ارتأى أن يكون معنا. ونعتذر مرة أخرى لأننا تأخرنا. الآن هو في سنغافورة وفي مكتبه، والتوقيت تقريبا الآن حوالي 5:30 مساء. فنعتذر لكم مرة أخرى، ونشكركم مرة أخرى جزيل الشكر والعرفان على قبول الدعوة. شكرا لكم بروفيسور، وإلى لقاء آخر إن شاء الله.
بارك الله فيك، شكرا، مع السلامة.